If you happen to be lucky enough to own a 4K capable device and are watching this, you probably still can't see this thing. That's because it's small. The question is, what does small mean for 3D printing? I think that's one of the questions. There are a lot of questions. Let's go. This video is sponsored by PCBWay. So this is a video I tried to make a year or so ago, but it got sidelined because it was quite a big topic. And that's not really changed. In fact, it's probably got worse and bigger since then for reasons I'll get onto. What I want to cover here is what small means with respect to FDM, how small you can go when 3D printing, what expectations you should have at that size, a lot of tips and tricks along the way, and also why the humble 2018 Ender 3 might not be entirely obsolete yet. We're going there. So first up, what is small? This is actually at least an easy question to answer. Small is, well, small. The game changed hugely in 2021 when a paper came out called A Framework for Adaptive Width Control of Dense Contour Parallel Toolpaths in Fused Deposition Modelling. And you can't say that in one breath. I still maintain that we should be forced to write YouTube titles like this, but this was the premise for the Arachne slicing engine, which was implemented in Cura 5 and covered by, oh yeah, me at the time. It later found its way into Prusa Slicer and thus into every other slicer out there that matters. What it does, or one of the things it does, is prints thinner lines than the size of the nozzle in very specific areas, and thus it exposes the potential to put more details on a model for the same size nozzle on the same machine. And this kind of renders a 0.2 nozzle obsolete for printing miniatures. Kind of. We'll get to that. But this change to Arachne allows us to print objects that are a lot smaller than we might think possible. With a 0.4 nozzle, we can make objects that appear impossible, but it works. So that's the easy question out of the way. The next thing is the smelly elephant in the room that is resin printing. Resin machines have higher horizontal resolution than FDM, and that's unlikely to change, so resin is always going to be the ultimate solution for printing miniatures or small things. But most of us, I guess, don't want to do resin in our houses because it's smelly and messy. So this is why we're trying to get the best out of our FDM machines. You could even be an owner of a resin printer, but you don't want to get out all the messy stuff. I have one here, but it doesn't mean I want to use it. Let's move on to some of the tips, and the first one I want to tell you about is wet filament. This is probably the single most important thing I can tell you about. PLA isn't normally that sensitive to humidity, but the differences when printing small things is surprisingly vast. I suppose it's a combination of the size of the stringing relative to the model, but also you don't have much surface to wipe on. In terms of which filament you should buy to print with, I actually recommend this stuff, which is Creality Hyperfilament. It's just because I found that it works really well. I don't know why, and specifically in the colour grey, other colours don't seem to work as well either. It does, however, seem to suffer moisture just as much or perhaps even more than normal filament, so you definitely need to dry it even when it's new and you take it straight out of the packet, because it's probably not dry then either. In terms of the hardware I've been using to make this video, I have made tuned profiles for the K1 Max, the Prusa Mark IV and the Mark IVS, the Prusa XL, the K2 Plus. Yes, I have one of those now. It's probably going to be reviewed next video. The SV08, the Bambu A1, the Bambu P1S, and that will of course work on the X1, the Ender 3 V2, and a direct drive Ender 3. That's a lot of printers. I think that's all of them. I've already shared the profiles with Patreon users so they can access them if they have any printer on that list. If you don't, or you want to make the profiles yourself, here's the main things I have found in the order of importance, roughly. It's not everything, but these are the important things. You want to have a layer height as small as you have time for. Print time gets a lot longer as you print lower layer heights, and I know you think, well, it's a miniature, but you can be up to 12 hours or maybe even more if it's a large miniature and you're using a really small layer height. You'd be surprised though at how little difference you see to the naked eye between 0.1 or 100 microns layer height and lower. It does look better, of course, when you print at lower layer heights, especially when you're looking through a macro lens, but it really does come down to how high quality you actually want out of that particular model and how long you want to spend printing it. I actually went down to 30 micron layer heights, that is 0.03 millimeters, and, well, you can see how nice it looks. Speed and acceleration. This is really important. You cannot afford to have any speed-based artifacting on your part, and you also want the cooling to work properly. If you know your speed benchies, then you'll know that the chimney is always the terrible part of the speed benchy because the cooling is not able to keep up. Now imagine your whole model is smaller than just the benchy's chimney, and you'll get the idea. You do not want to be printing at speed benchy speeds, or even normal speeds. You want to be printing around 30 millimeters per second for most settings, and you want the outer wall to be even slower. And the same applies for accelerations. If you pretend your printer is an Ender 3 and go for about 1000 millimeters per second squared, that's plenty for acceleration. I mentioned Arachne already, but for a 0.4 nozzle you absolutely want that to be the slicing engine. You also want to tweak the parameters a bit so that the minimum line width and the feature size is smaller, otherwise you'll lose tiny details like cat ears. This is out of spec of what Arachne is supposed to be able to do, but it does it fine. You can always check the preview to ensure that you don't have any floating parts, especially things like the tops of sticks that for some reason, miniatures always seem to be carrying swords and sticks and spears and stuff. Those are always the most difficult parts to get right, especially if they need supporting. And speaking of supports, they are a necessary evil on probably about 80% of miniatures, perhaps more. Fortunately for you, I've done the hard part and I've tuned them in my profiles, so on most printers they will just snap off quite easily, surprisingly so. This was achieved mainly by making the distance between the part and support big enough, but also not too big that you get drooping. And also tuning the interface settings. It was honestly a pain in the backside. The general overview is that you should use organic tree support in most slicers, although the Bamboo branch of slicers, which also includes Orca, they seem to support in places that you don't need them to, and they do some other weird things as well. So I've got to say that Prusa Slicer is definitely better for supported models that require quite complicated tree supports. Other minor things you need to consider include making the model stronger by increasing the infill and the wall count, especially if you have supports to remove. You want arms and legs to stay on and support to come off. Seams should generally go to the rear of the model because, well, it's the rear and that just seems to work better. You probably want to consider minimum layer time. It's often set up correctly, but the minimum speed underneath it can sometimes make it do the opposite of what you expect it to. So yes, do that. And finally, there's this setting that you might consider. It deals with how fine a resolution that the slicer will process G-code to. So obviously we've got really small models. We want to be processing the G-code down to a very fine resolution. So you almost certainly need to adjust that. If you're printing with a 0.2mm nozzle, then we need to talk about that. I've got two identical prints here with each size nozzle, and the difference is probably not as big as you might have expected. There is a reason for this if we think about it. Nozzle aperture size is important for horizontal detailing. The difference between a 0.4 and 0.2 nozzle on the sidewall of a print is really not that great. The main benefit that you get from a 0.2mm nozzle is on the top surfaces of a model, and the vast majority of miniature prints, at least as far as I've seen, are broadly vertically dominant models, if that's a term. If not, I've just made it up. The details are on the sides of the model and not on the top, is what I mean. They could be on the top of the model, and I'm sure there are exceptions to that rule, but generally they are not. So the biggest factor that's affecting detail is actually the slicer parameters and the layer height, and not the nozzle physical size. Of course, the ideal nozzle for this is still 0.2 because it is smaller, so I think it should be a consideration, and if you do have access to a 0.2 nozzle, then yeah, sure, you should be using it. But if you don't, or you don't want to get a 0.2 nozzle, or you just don't want to change nozzle, it's far from necessary, and it does increase the print time when you use a 0.2 nozzle as well because the walls are thinner. So I suppose the TLDR takeaway there is that it doesn't matter as much as you think it does whether you use a 0.4 or 0.2 nozzle, but the 0.2 nozzle is still better, if that makes sense. So next we need to get onto the interesting stuff, the actual results, and I found some fairly uncomfortable things actually in terms of the results. For some of you, perhaps especially if you've bought expensive printers. Bear in mind that what follows are empirical observations, and they in some cases outright disagree with the established knowledge. That's not unusual, to be honest. So the best printers hands down for the job of printing miniatures are the Prusa printers. This includes the Prusa XL, which I was surprised about because it's a large printer. It and the Mark IV's are the best printers that I have for miniatures, and it's not even close in my opinion, and I'm sure that you'll agree when you see the pictures on screen. The next best printer was, I think, the Bamboo A1, followed by the P1S. I imagine you didn't come here for a best printer ranking, but these two were also pretty good. The P1S did really struggle with failing prints, especially on a 0.2 nozzle, until I noticed that they have some weird setting in the slicer. The ordering with the wipe and retract are at odds with every other printer out there. And that just goes to illustrate that just a slicer setting can make a big difference rather than the actual hardware. So I changed that and it seemed to solve the problem. Bamboo printers do seem pretty rigid and capable, and they do produce good miniatures. It starts to get a bit interesting beyond that point because the K2 Plus seems to be able to make decent miniatures. I'm actually quite impressed with that printer so far. It's obviously new. If you're thinking of buying one, I currently have no reason not to recommend it. Testing is still, of course, ongoing, so that's not an official recommendation. It did maybe as good a job as the K1 Max. I think maybe a bit better than the K1 Max. Due to the excessive rigidity of the machine, it's built like a tank, to be honest, and things start to kind of blur with the remaining Clipper printers from there. They're all okay-ish, but none of them are particularly outstanding compared to the Bamboos and the Prusas, until you get to the Sovol SV06 Ace, which for some reason, I don't know if I've broken it, but I couldn't tune this out at all, and I'll keep trying, but at the moment, yeah, that's not good. But I got to thinking at this point, why is Prusa so much better than everything else at this scale? This is Steve. I bought Steve in 2020. He's a Bowden extruder printer, meaning the extruder is away from the hot end, and he's an Ender 3 V2. It's not a printer that's known for good quality, but that's what's weird. I found this print that I'd painted, if you use the term very loosely, it's not a bad job if you know the context of the piece. It's actually meant to look like it's a few hundred years of decay, but the print quality is excellent, isn't it? And I printed this in maybe 2020. And I just coincidentally found it when I was tidying up. Speaking of excellent quality, do you know what this is? That's right, it's the sponsor segment. It's a PCB made for me by PCBWay. If you need PCBs manufacturing, then PCBWay can pretty much cater for any requirement you have, including assembly, like so. Ordering PCBs is surprisingly frictionless if you use the Quick Order PCB page access through clicking the Quick Order link on the normal PCB order page. You can also manufacture parts using PCBWay out of things like aluminium using CNC machining. But also, if your design is more complicated, then you can get it manufactured by PCBWay using metal FDM processors. They can also print using resin, and comment below if you think I should send them over a miniature STL for them to print so we could see what that looks like. That could be fun. There's also a load of other services that I haven't mentioned in this section, including some very advanced stuff, so whatever you need fabricating, PCBs or otherwise, please use the links in the description to check out PCBWay's services. There's a new user coupon there too. Thank you PCBWay for sponsoring this episode, and back to Steve's print quality. And yeah, we do get pretty decent miniatures off this thing. The gantry has like 5mm of plate on the right hand side, but it still prints these models better than some of these new machines somehow. This is Janet. Janet is from 2018, and Janet has a direct drive mod. That's not what comes with the standard Ender 3 from 2018. It also had a Bowden like Steve. Janet's problem is that she cannot be easily upgraded to include things like Pressure Advance, not without changing the board, I don't think. Her prints are going to suck. Or not. This is honestly not that bad, is it? So what do Steve, Janet, Joseph and Joseph have in common that all these other printers do not? And how does Bamboo fall into this equation? I actually have a hunch what's going on here, or a couple of ideas, but let me know in the comments what you think. It will be interesting to see if you have the same ideas as me. Ultimately, there's a few possibilities that come to mind of what's going on here, and it will be interesting if I can find the time to try and dig into this, but it could be quite a rabbit hole. Anyway, don't let this distract us from the actual results here, which is that even the lowest quality end of the prints from the working printers are actually a remarkable achievement from an FDM printer, often while using a standard 0.4 nozzle, and sometimes even using a high flow nozzle. The camera always makes them look worse, which is something I do want to address. Everything you see on this video will look worse to you than it does to me, because that's just what cameras do to FDM prints. It's something that us videographers, or supposed videographers, are well aware of. So what else can we talk about? I guess the XL is a multi-tool machine. It would be fun to see if it's accurate enough to put all the nozzles in the right place at a 50 micron scale. I'm inclined to point out that this is actually a very hard ask for a tool changer, Most IDEX printers or tool changers would find this very difficult because you're putting things on and off a mechanism and you've got to make sure every time that they sit at the exact same point. There's almost no tolerance here. Getting this to print accurately would be a feat of engineering. That is quite impressive. I will see you next time. Thank you for watching.